Today I'm going to talk about the river landforms that are formed in the upper course and the river processes and weathering process that help create them. So the first landform I want to talk about is a V-shaped valley, and the reason it is called a V-shaped valley is when we look at the cross-section of the river, it looks like a V. However, this valley would have at one point it looked much more flatter like this, and the river would have been in the centre, and it would have been certain river and weathering processes that would have changed this valley shape to create into a V. So how do we get the shape of the valley go from this flat shape into the traditional V-shaped valley? Well, we're in the upper course, so we know that the upper course rivers have low discharge because no tributaries have added water, and then because it hasn't got a lot of water in it, therefore it hasn't got a lot of energy, kinetic energy for eroding. So when it does erode, it has to erode in a very focused way. So in the upper course, we have vertical erosion. It's where the river erodes down deeper into the valley. But the question you might ask is, well, why do we get vertical erosion? And the key question there, or key answer, even, is gravity. Gravity is having such a big influence on the river here. We're at such a high altitude, so gravity is pulling that water down. So when it does have enough energy to erode, it will erode down into the valley. So over time, this flat shape starts to change, and as we go down, we can see that the river has eroded down, and therefore we're starting to get this steeper river with steeper sides as the river erodes down. So that's the first step in why we get these V-shaped valley. But now we need to see how does it go from this shape into more of a V. So the river has eroded down through vertical erosion, processes like hydraulic action, and it's got this deep valley. But what it's created is it's created these steep sides which are suddenly exposed, and they're exposed to other processes, and the process they're exposed to that shape the valley are weathering processes. So what we would start to get happening here is in all the kind of cracks in the rock, we would get water go into them, and that's where we get the processes of freeze thaw, which we've already talked about in another video. This would therefore weaken the rock, and then over time, eventually, all of that rock that's on the side would suddenly break down, and therefore it would break down and go through gravity into the actual river. And so what we would get is this side that was suddenly very steep is not so steep, but if it happens on both sides over time, we would get this V-shaped valley. And that's also other processes that could occur in this because of the steepness would be mass movement. So we could also get processes like slumping occurring in this area. That's how we get this valley, which started flat, but over time through vertical erosion and weathering, it ends up in this lovely V shape. All of that weathered material that was on the sides, that now ends up, due to gravity, falling into the river. And once it's fallen into the river, that actually helps to erode the valley down even further, because we get all those rocks and boulders. They are actually helping the process of abrasion, which wears down the river bed and making the valley even deeper. The next landform we need to talk about in the upper course is called Interlocking Spurs. What the river's trying to do in the upper course is it's trying to find the easiest path because it doesn't have a lot of energy to erode laterally. So every time it comes across a hard bit of rock, like I've scribbled on here, the river will go round it and erode round it to find the softer rock either side. What these hard rock areas are called, where that are left jutting out, that is what we call interlocking spurs. So if you look at the river from above, it would look a little bit like a zip with all the little teeth kind of meshing in together, and that's essentially what we've got here. The river's trying to find the easiest path. When it comes to this hard rock, it goes round it and erodes round it, and it creates these things called spurs. The last feature I'm going to talk about in the upper course is waterfalls. Waterfalls form where a river flows over an area of hard rock, but then followed quickly by an area of soft rock. What happens when the river goes over this area of soft rock, it erodes it quicker than the harder rock through the processes of hydraulic action and abrasion. And because it's eroding quicker than the harder rock, it eventually creates this step in the river. So over time, this hydraulic action and abrasion continues to erode the softer rock, and this step is eroded away until we get this shear drop, which is what we call the waterfall. This water falling over the shear drop continues to erode through the pure force down in this area below through the process of a hydraulic action. And what it eventually creates is it creates something called a plunge pool. This falling water doesn't just erode downwards into the plunge pool, but it also erodes back into the soft rock behind it in a process known as undercutting. As the water coming over the waterfall continues to splash back and undercut this rock, it continues to go back further and further, cutting further into the rock. And what it does is it makes this area of rock over here, the kind of resistant rock, which we call the cap rock, it makes it incredibly unstable. And eventually what will happen is it undercuts enough that this actual cap rock will collapse and fall into the plunge pool. So what we've seen happen here is the cap rock has become so heavy, it's been unsupported because it's been undercut and it's collapsed, and we can see all the collapsed rocks have actually fallen into the plunge pool. They actually get moved around in there and they help the process of abrasion, so they make that plunge pool deeper, and they can also, if pushed around enough, help continue to undercut. Now we've got a new position of the waterfall and we can see the old position of where it is. So what happens over time, this undercutting process continues, and it continues, and over 1,000 years what will happen is the waterfall will retreat up towards the source over many, many years. As a waterfall retreats back towards the source, and this process of undercutting and collapse, followed by more undercutting and collapse, it leaves these really steep sides either side of the actual waterfall, and this is known as a gorge.